Symposium has a mission of identifying future technologies and bringing them to the market. So we are here to help researchers, creators and innovators to bring their technologies to the market.
I'm feeling inspired, frankly. When I look around at the people who have been building this with us, these are people who believe in what we're doing, and it's something very different that we're introducing. Collaborative R&D in this industry where people are making so much money on the product lines and their competitive advantages. And the OCP has already solved the idea of coming together and creating open source hardware. Now to say, where are we headed, where are we investing our R&D efforts, and how do we start to open up to each other in somewhat maybe our future advantages, that's really hard to do. I'm feeling very proud and inspired of the people who have chosen to try to take this thing on with us. After years of building this, we have a community around us that's inspiring, and we've built this thing together. So it's really the connections of the people that we've built this with.
If you want to get inspired, be inspiring, and push your limits to achieve what is probably not impossible, you should join the Future Technology Symposium, because you will see the leaders and innovators in the industry who wants to challenge and be challenged, and who wants to get exposure to the hyperscalers, to the people from the universities and startups as you creating innovative technologies.
Jisk slaví 44. narozeniny fan.
Good afternoon and welcome to the OCP Future Technology Symposium. I'm Lesya, I'm chair of the Future Technology Symposium, and I would like to invite you to take your seats and we will kick off and start the first presentation. So today I'm extremely excited about the technological tracks that we have. So we will start with the keynote. Then we will have AI HPC technological track with 4 presentations. And then after that, that will follow up by data center sustainability. Okay? At 4 p.m. you should be here for a technology demonstration session. We have 7 startups from the Europe and 1 startup from US describing their technologies. So I'll explain you how we're going to organize the technology demonstration tour. So join us at 4 p.m. here. And now I would like to start with the keynote presentation on AI revolution is upon us, HPC application. So I would like to invite Allan Smith, who is actually the founder of the symposium and initiative. He used to work for Meta and was the head of the hardware development and also had experience with NASA. Our second guest speaker is Allan Cantle, who is also the lead of the HPC sub-project within the OCP community and also the CEO of his own company. Welcome, Allan.
Can I do a different screen? Different screen. Thank you, everyone, for coming. I'd like to welcome up to stage my friend and colleague, Mr. Allan Cantle. Allan is a true systems guy. He's really well-versed to speak on the moment of AI that's happening with our high-performance computing systems. Going back to his days, early stage, real-time heterogeneous computing applications and simulation. He was an early pioneer in FPGA development for data flow applications. He has founded multiple companies, been acquired multiple times, Nallasway, Nallatech, and now he's lately been doing heterogeneous HPC applications and doing AI accelerator inference development with, say it again? Untether AI. He is also currently our HPC sub-project technical lead. So please welcome to the stage my friend Allan Cantle. Wonderful. Yeah. So we're in a very interesting moment with Future Technologies Initiative. The purpose that we view for ourselves within this community is we mine the future. We like to look around the corners and see what's coming and build pipelines of ideas and talent to solve the next generation OCP problems. We cannot do that today because the future is manifesting as we speak. ChatGPT was released in the fall. That was months ago. And it's already upended our industry. It's upended our society. I would argue it might be one of the biggest technological advancements of our lifetime, and it's happening right now as we speak. So we wanted to take a moment to talk about this, not from a boogeyman perspective, but from an opportunistic perspective, and say, how do we start to bring ourselves together and just orient around what is happening in AI? So some quick statistics. ChatGPT was released. It's a large language model coming out of OpenAI. It was released in the fall. It took 2 months to get 100 million users. That makes it the most viral application in our society's history. The next one was TikTok. It took 9 months to get 100 million users. Instagram, 30 million users, 30 months to 100 million users. LinkedIn, 8 years. Those are the top 4 applications. So the future is accelerating right in front of us. It's manifesting in all sorts of interesting ways. One example I like to think of is Google's Bard technology. Google's been working for decades, plural, in AI research, starting with Andrew Ng at Google Brain. They released, as a response to ChatGPT, their version of a large language model, Bard. There was a factual error in the representation of what Bard produced on its demo, and a scientific researcher pointed this out. Anybody know how much the Google stock price dropped that day? $100 billion, 10% of its market cap. That's what's happening in this arms race right now. So I think a useful frame of reference for us is the researcher Ethan Mollick out of Northwestern. He's outlining 3 orders of disruption that he believes will happen around the current AI revolution and generative AI. The first is productivity of people. So we're going to start to understand what these tools can do. This is when we're seeing things like text to image, text to video, and all this AI agent development that's happening right now. So we're clearly within the throes of this first thing, and it's happening every single week. If you follow the news, there's a new company being generated, a new application being developed from text inputs to language prediction. The second is we probably need to reorient or reorganize how we work. And I can tell you, having worked at Meta and having friends at Google, we are in the throes of this right now, trying to figure out how to become AI organizations. One example of this is agile development. When we already have, in the first few months of this technology being released, 20% developer efficiency happening. How do we organize scrums in agile development? We don't know. What are the skill sets? What are the talent? Where do human beings add value and place into this? The third, which I think is coming, I don't think we've wrestled with this yet, is that work will meaningfully change. So we are on the cusp. I have not seen the first yet. I'm expecting to see it any week. The first AI agent that is reviewing and auditing an AI product. They don't even need us, right? These systems. Where do we plug in? Where do we add value? How do our societies shift around that? That's the moment that's happening right now. And again, none of us views this as a boogeyman moment. We view this as a huge opportunity for our industry. So Allan's going to talk a little bit about how this touches high-performance computing and HPC, but what I wanted to do to baseline and transition into his part of the talk is talk about training versus inference. I'm speaking to a pretty knowledgeable crowd, but so I assume you all know about this. Just my experience working on these systems for the last 5 years. 3 years ago at Meta, it might have still been called Facebook at that time, we were developing 256 node systems for training. We were working with like 350-watt GPUs, right? Guess what we're doing now? Anybody know how many nodes it's taken to train OpenAI at Microsoft? Tens of thousands. Did you all watch Ampere's talk or Broadcom's talk where they're enabling 30,000 GPUs to be threaded together? And these are no longer running at 350 watts. They're running at 700 watts and 1,000 watts is on our roadmap. So we're reaching a really incredible inflection point of this technology and scale, and I'm going to invite Allan to talk about some of the opportunity we see here.
Thanks, Allan, and hi, everybody. Yeah, so we're seeing these massive exponential scaling challenges in AI, in the machine learning and the inference side of things. But if you really dig under the hood of where these challenges are coming from, they all come down to energy, and the energy consumption is getting way out of hand. And when you look into where is this energy being burnt, the actual compute is actually a very tiny fraction. It's the moving of the data, be it on chip or off chip, that are causing all of our challenges. Now, we've obviously known this in the industry for a very long time, and our silicon geniuses have been busily working on creating lots and lots of different processors, heterogeneous accelerators, that are tremendously efficient at a particular function. And so we've been dealing with this at the system level. And as Allan mentioned, I work alongside Untevra AI as a chief systems architect, and they are focusing on AI inference. Their chip cannot do the machine learning side of it, the training part of it, because the inference is a much lower precision of math. They're realizing that lower precision works well, whereas the training needs high precision math. And not only that, they focused on putting the compute at the memory itself to minimize that energy consumption. And so you're finding that tens of watts for this dedicated accelerator, inference accelerator, compares to the hundreds of watts of the GPUs that you just heard about.
Maybe even 1,000.
So, maybe even 1,000, yes. And so we're seeing this plethora of, and there's hundreds of startups with all these different accelerators coming to the market. Not only that, we're hearing a lot about chiplets now, where we're putting multiple chips inside a single package. And there's no more success in the HBM, the high bandwidth memory coming on package. The reason that is on package is because we've got multi-terabytes per second of bandwidth required. And if you tried to do that in external memory, you would have hundreds of watts of power just to move that data at that speed. And that's why HBM has been so successful, because it's the only way, really. But we really need to, but the reality is, this silicon and stuffing everything in a package is one thing, but we don't build supercomputers inside a single package. We use thousands of these devices to make our supercomputers. And so we really need to take a step up. So a very good example of this is Google just released a couple of weeks ago details of their TPU v4. And the basic tenet of the entire article was that system architecture matters more than microarchitecture now. We can save a tremendous amount of energy by focusing on the system architecture. And that's what we need to do. And the way I look at this has been something I've been passionate about for many years. The way I look at this is we need to look at our industry from an energy-centric computing light. We've heard about processor-centric. We moved to data-centric over the last decade and more. But we really want to put energy-centric. We've got to work out a way of thinking about energy first when we architect our solutions to certain problems. The reality is, though, Google, NVIDIA, they're doing a great job of this, but it's very proprietary. And so we need to really get open collaboration at the system architecture level. The reality is we have different disciplines. We need experts from every discipline who very, very rarely talk to each other. As a systems engineer, I'm a jack of all trades, master of none. I rely on an expert in the thermal world, the infrastructure world, the mechanical, the electrical, the optical, the software. And we need to collaborate across those traditional silos to come up with better solutions. And that's what we're trying to do in the OCP HPC sub-project that I lead. We are completely radically re-architecting at the system, at the pluggable system level, into a modular, what we call a wall of compute technology. And we're a small team of individuals that come from various companies, from various disciplines, but I'm actually moving into that role full-time. I'm going to be a full-time volunteer on the OCP HPC sub-project. And I need experts from all disciplines. So my call to action to you guys is if you've got a particular expertise in any of the disciplines, we really want to make this from a conceptual idea that we have in the work group at the moment into a physical product and actually begin to build a maker community around HPC architectures at the system level. So thank you very much.
Yeah, wonderful. So we heard a call for action there to join the HPC sub-project group. We're going to be designing energy-centric systems architectures, and we need functional experts from everyone who's interested in deploying HPC. So please meet with Allan, come join his group. It's all on the website, the OCP website.
Yes, there's a wiki, OCP HPC wiki.
Wonderful. And then we have several talks today that are going to dive into, so we're about to go into the AI portion of the message. We have an interesting talk from Laura on quantum. We just got done talking, so I'm very excited about that. And then I want to highlight also Rich Kenny's talk around energy optimization design. So he's got a demo back there with Interact, and he's going to give a talk later on sustainability. So you can see our entire theme is about power consumption, resource consumption, and the massive loads that are hitting our systems these days. Before we start the program, any questions that you want to get off of your head on HPC, AI, generative, ChatGPT, stock prices, politics, religion? Yes, sir. Let's do it. Ethics. I would love it. Lesya, can you give him the mic?
So power efficiency definitely is very important in HPC. What about the reliability and availability? Is that also important? Are you guys working on that area? Something unique?
No, absolutely. The reliability and availability is obviously super important, and it's not a complete area of focus right now for us. We're a very small work group. We're trying to re-architect at this level, but fundamentally, we're not changing much of the infrastructure. We're trying to redo the way the system architecture is put together. But if we're successful in this, you would be able to build an NVIDIA NVLink system with their software stack. You could build a standard, a standard server stack with the same architecture. So you'd have the same level of serviceability, reliability, etc. But we are also trying to innovate to another level as well. And those are very big topics. In fact, security is probably the one that gets hit across my head the most. So we are trying to, and that's the beauty of working in OCP. There are many sub-projects that we can pull their expertise in so we all have our own niche, but we try to collaborate together to make sure we can pull their expertise into us as well. So, but good question. It's a tough challenge, but we've got to take it on. There is no choice in my mind.
Open if you want to share the reliability statistics of Meta's systems on AI.
Yes, there is a DC SCM, the security module. Yes, there is, yes.
Excellent. And on the ethics front, I would just point you towards Ethan's work on Tristan Harris's work, the Center for Humane Technology. He seems to be the expert in how to adopt and create humane transactions with technology. Anything else on your mind before we get started? Thank you so much for being here. We're very excited to share our program with you.